So in this part of the video I'm going to show you how to bring in a tool that you've created using Inventor and how to bring it into RoboDK and attach it to the robotic arm. So I'm going to start by opening up the robot, which in our case is the IRB 120. So that's now in position, and then I want to open up the tool, which is here. So this was made using Inventor and exported as an IGES file, which makes it compatible in RoboDK. So they're both in now. So what I just need to do is click the tool and drag it below, and you can see that it's just snapped on into the right place there. You can just hide that reference frame to make it a bit clearer, and there you can see it. So the next thing I need to do is, because at the minute it's recognizing the tip of the tool as being out here when I really need to move it to there, so I want to go Shift Alt, and I want to click this frame and just drag to the tip. I'll change my view to the left here. So you can see I'm just a little bit off still, so I need to adjust it again. And that should do that. So that's how to bring in a tool and attach it to the arm and position the tool center point at the tip of your tool, wherever that is. So the next thing I want to talk about is reference frames here, and these are important when you're importing from AlphaCAM, because this is where the origin of the AlphaCAM file will snap to once it's brought in. So to create a new reference frame, you need to click up here, and you'll see that it's brought in out here. So if I double click, it brings up its coordinates in RoboDK. So I want to make it reference position with respect to the robot base, which is down here. So now that it's aligned with that, you can change the coordinates to suit wherever you would like it to be imported. In my case, I need that point to be out here, so I measured from the base of the robotic arm in GMIT's lab to the front of my piece, and the measurement was 200. And using ABB's drawings, I know that it's 90 millimeters from the front edge here to the center in here. So if I want it to be 200 here, I need to hit my coordinate to be 290. And I want the Y coordinate to be 0, so it aligns with the center of the robot. And that's how to position a reference frame. So after selecting your robot station in AlphaCAM and launching robot integration, this is the window you'll now be brought to. So you're now in RoboDK, and you can see the toolpaths from the AlphaCAM programmer there. I'm just going to turn on the visibility of the piece. So now you can see the piece is there and the toolpaths are all there, and it's the same as the robot that's in GMIT Larafrax lab. So the first thing you'll want to do when you bring in, I've jumped a step ahead now, but your tool will still be the flat 2mm cutter that was used to create the program in AlphaCAM. So what you'll need to do is right click on the tool here, select tool, and then select your new tool, and that will change it to the marker tool that we want to use. Flat 2mm cutter will be listed here. You just simply click it and delete it. So now after changing the cutter, you can see that this program needs to be updated. So you just want to right click and update program. And now you can see that the toolpaths are all updated. So this program should be ready to run. So I'll right click and run. So you can see now that the marker tool is following all the toolpaths. Let's change views. So you can see that it's not digging down into the piece. Everything seems to be running correctly there. So should finish now. Yep, and that's the end of the program. So if you're satisfied that the program is simulating correctly, the next step you want to take is change down the speed. So I've just double clicked that there, and I want to go to program events. So it's on 1000, which is very high, so you want to change that to 100. And okay, update. And it's finished updating, so I can just close that now again. And the next step then is to right click main program and select your post processor. So this is a list of post processors, and these will essentially convert that program into a language that a certain robot will understand and can work from. So you can see listed different makes of robots here, In our case, the one we want to use is ABB Rapid Custom PRG. PRG is the file extension which the teach pendant in letterfrac can read. If it's another file type, it might not pick up the file, so we want to select that one. Okay, so that post processor is now selected. I can right click and hit generate robot program. So that's just a notification message. You can minimize that. So this is now the code that has been outputted by the program, and this is what you would take to the ARM to run. But there's some extra lines that have been created in here because the program was originally made in AlphaCAM. You can see some of them here, and these are unnecessary, and they actually won't allow you to run the program. On the teach pendant will recognize these as errors in the coding, so these need to be taken out before you save it and bring it to the teach pendant. So I've made up a diagram here of what needs to be changed and what needs to be deleted. So the first step is to mod main program. This needs to be changed to module_mod prog1. So you go to module_mod space prog1. So that's done, and the next step then is to proc main program needs to be changed to proc prog1. So that's here. Delete that. And open bracket and close it. Sorry, that doesn't need to be there actually. And then the next section to be deleted is starting after using nominal kinematics. So this can be selected here and dragged all the way down to here and deleted, and just backspace to bring the lines together. So that's that section taken care of. And then the last bit to go is these bits here. These are all due to the AlphaCAM file, so these can just be removed. So again, click, drag and delete them all, and backspace again to bring the lines of code together. So the final step then is to change the speeds, which are here. Now the ones that would have originally been created as a V1000 have been created down to a V100, but you still have, this is still a problem, V250. And the problem with this is that it's not a standard speed on the ABB teach pendant, so this creates an error when you load the file on. So these need to be changed down to 200, which is a standard speed on our robot. So you just work your way down through those and change them to 200s. And when you reach the bottom, you should see end module. Yeah. So you want to just file, save as, save it to your desktop. So this can now be renamed .prg. And once that's saved, that can simply be put onto a USB, brought down to the ABB teach pendant, and the steps for loading it will be listed after this video.